Today's presentation is on CET's innovative approach to identifying and removing I&I called the Mini Basin approach. Our presenter today is Alton Whittle. Alton graduated from Lehigh University with Bachelor of Science in Civil Engineering. A registered professional engineer, he has 17 years' experience in the environmental field, primarily in water and wastewater. He serves on CET's Board of Directors, manages CET's Facilities and IT Department, and is also responsible for CET's GIS, hydraulic modeling, and flow metering programs. Lately, among his other duties, he has been spearheading CET's asset management services and developing tools and applications for web-based mapping and project management.
Thank you. Today we're going to cover a brief overview of the control basin approach and how to deal with excessive I&I. Historically, like most in the engineering field, we tracked I&I based on compiling all the contributing factors, such as rainfall, groundwater, storm intensity, snowmelt, etc. This led to some significant difficulties, however, comparing various storm events to one another. For example, 2-inch rainfall in February may be completely different than a 2-inch rainfall in June. This approach always left us with a feeling of uncertainty and a little bit of unknown. Due to the issues with the historical approaches to evaluating I&I, CET developed what we called the control basin approach. This approach selects one basin, which is used then as a measuring stick for evaluating the impact of the wet weather event upon the system. A control basin allows you to compare flows for similar wet weather events to one another. It measures all your combined effects on the system from the contributing factors from the wet weather event. When you're selecting a control basin, you're looking for a small basin, around 100 to 150 EDUs in size, that does have a sufficient reaction to wet weather events. It's something that you don't have any planned growth or rehabilitation in, something that will be constant for future use. Here is an example of using the control basin to measure the impact of various wet weather events. Each point on the chart represents a wet weather event, and the chart compares the date on the x-axis to the peak impact of the storm on the y-axis. Using the control basin approach, we can assume that events falling at the same value on your y-axis are comparable to one another. For the collection system in the graph presented here, we noticed a developing trend in its reaction to specific sized events. For example, surcharging in the system was experienced during any event that resulted in a flow of 0.3 mgd and larger. And even during larger events, wet weather overflows were experienced whenever the control basin reached above 0.6 mgd. Taking the control basin concept to the next step, the collection system was divided up into bite-sized chunks, which we called mini basins. These mini basins were small branches, typically ranging in size from 100 to 150 EDUs. Metering data were collected for these mini basins in order to track their individual reactions to wet weather events. By graphing each of the individual storm points on this chart, it's easy to develop a curve that represents the basin's characteristics, how it reacts to wet weather, how it reacts to small events versus how it reacts to larger events. These basin characteristic curves facilitate several functions, first of which is the ability to comparatively rank different mini basins against one another. This helps you determine which basin is more susceptible to excessive I&I. As shown here, the blue line represents the highest priority basin, and the green line represents the basin that is not very susceptible to excess I&I. This lets staff prioritize where to effectively spend their time and their efforts and investments. Another crucial use of the basin characteristic curves is to demonstrate the effectiveness of rehabilitation. Once rehabilitation efforts are completed, subsequent wet weather events can be metered. These new points can be used to develop a new basin characteristic curve for post-rehabilitation conditions. When plotted together, the difference between the curves represents the level of excess I&I that has been removed. This can easily be coupled with rehabilitation costs to establish a cost per gallon of removal. This cost ratio can then be used to evaluate various rehabilitation methods or treatment options to effectively select the most cost-effective solutions. In closing, CET has implemented this control basin approach throughout numerous collection systems. We have been very successful at achieving quantifiable results in an effective and cost-efficient manner. Thank you for participating in today's discussion. If you have any additional questions or would like to discuss this further, please don't hesitate to contact me. You may reach me at awhittle@cet-inc.com or call me on the phone at 717-541-0622. Thank you.